If you've spent any time at all in VR, you know this feeling. That familiar weight of a controller in your hand, right? It's your gateway to these incredible virtual worlds. But for all its precision, it's still a stand-in. It's a prop. So what happens when we finally put it down? What does a truly hands-free future in VR actually look like right now in 2026? All right, let's dive in.
So, here's how we're going to break it down. First, we're going to question if the controller's days are numbered. Then, we'll look at the 3 key technologies stepping up to take its place: our hands, our eyes, and our voice. After that, we'll see how they all come together in what we call a multimodal future, and then finally, we'll take a little peek over the horizon at what's coming next.
For years, controllers have been the reliable workhorse of VR. They're the standard for a reason. They give us that super precise tracking, the satisfying click of a button, and that really important tactile feedback. But for all their strengths, they've got this one fundamental flaw. They are constantly reminding you that you're not actually there.
And that right there is the crucial point. Every single time you press a button to grip an object, your brain gets a little reminder that you're just holding a piece of plastic. It's a proxy for your real hand. And that little reminder, it breaks the illusion. It creates this barrier between you and the virtual world. And it just yanks you out of the moment, killing that feeling of truly being there.
So what's the trade-off here? This slide lays out the core dilemma perfectly. With a controller, you get that high mechanical precision and you get haptic feedback. You can actually feel the buzz. But you sacrifice immersion, and just as importantly, accessibility. Natural interaction? It completely flips the script. It offers this incredible sense of immersion and opens up VR to a way bigger audience. But you lose that physical feedback, and your precision can kind of depend on the lighting in your room. This is the exact problem that controller-free tech is trying to solve.
So let's move on to the most obvious, the most intuitive replacement for the controller: your own hands. The idea is so simple, right? What if you could just reach out and interact with the virtual world exactly the same way you do in the real world? And that is hand tracking. It uses the standard outward-facing cameras that are already on a headset like the Meta Quest. Then, these super sophisticated algorithms watch your hands and create a perfect one-to-one digital twin of them inside VR. No gloves, no extra gadgets. This tech has gone from being an expensive add-on to just a standard, built-in feature on modern headsets.
And you know what's really cool? It's not a one-size-fits-all solution anymore. What's so interesting here is seeing how specialized the tech has become. By 2026, developers can pick the right tool for the job. Default mode is great for just navigating menus, but for a super fast-paced game, you can switch to fast motion mode, which literally doubles the tracking rate. For social apps where you might be waving your arms around, wide motion mode uses predictive models to keep your hands in view even when the cameras can't technically see them.
The benefits here are just immense. First off, there's basically no learning curve. You already know how to use your hands. And studies show over and over that this direct interaction dramatically increases your sense of embodiment, that feeling that your virtual hands are your hands. It's also a total game changer for accessibility, removing barriers for people who can't use traditional controllers. Plus, it's flexible. You can sip your coffee or check your phone without having to awkwardly put down a physical object. But, okay, we have to be honest about the limitations, and there are still some pretty big ones. The biggest? No haptic feedback. You see yourself grab a virtual rock, but you don't feel its weight or its rough texture. Then there's occlusion. If your fingers cross over each other, or if your hand goes behind your back, the cameras can lose tracking. And the system works best when your hands are out in front of you, which can lead to that classic gorilla arm fatigue from holding your arms up way too long. Okay, so hands are for doing. But what about for intending? The next piece of this puzzle isn't about what you do with your hands, but where you're looking. This is the silent, but incredibly powerful input of eye tracking. Just think about it for a second. Where you look is a direct line to your focus, to your intent. It's way faster than any mouse or joystick. In VR, it can be used for literally everything, from making realistic eye contact with other avatars to aiming a weapon, or even just selecting a menu item simply by looking at it.
But maybe its most critical job is making high-end VR even possible on a standalone headset. It's a technique called eye-tracked foveated rendering. So the system uses these tiny little cameras inside the headset to see exactly where your pupils are pointed. Then it cleverly dedicates all the headset's processing power to rendering that one tiny spot in ultra-high resolution, while the rest of your peripheral vision gets rendered at a much lower quality. And the crazy part is your brain barely even notices the difference.
The performance gains from this are just staggering. For streaming content, this trick saves about 5 times the bandwidth. It is without a doubt the single biggest reason why untethered headsets can now produce visuals that used to be only possible on super high-end PC-tethered systems. It's not just a cool feature, it's a foundational technology for the entire future of VR.
So we've got hands for manipulation and eyes for intention. But what about the more abstract stuff? You know, how do you open a menu or change a setting or ask for help without pushing a button? Well, you use your voice. And listen, we are not talking about clunky, rigid commands like computer, open file. Powered by some seriously sophisticated AI platforms like Meta's Wit.ai, the voice systems in VR today are becoming conversational. They can actually understand the nuance and the intent behind what you're saying, which makes the whole interaction feel way more natural and fluid.
Here's a simple but really powerful example. Imagine you're in a game. Instead of fumbling through menus to figure out how to do something, you could just ask, "Show me how to cast a fire spell." The game's natural language processing understands what you want and can trigger an action directly. It just removes all that friction and keeps you deep inside the experience.
Okay, so we have hands, we have eyes, and we have voice. So which one is the controller killer? Well, the answer is none of them. And all of them. The future of VR interaction isn't about replacing the controller with one single new thing. It's about using a smart combination of all of them, playing to their individual strengths. This is what we call the multimodal future.
Think of it like a specialist's toolkit, right? Hand tracking is absolutely unmatched for direct manipulation. Eye tracking is for subconscious intent and lightning-fast aiming. Voice is for those complex, abstract commands. And yeah, the controller still has its place for high-precision tasks or when you absolutely need that haptic feedback. The best experiences out there are the ones that seamlessly blend all these tools together.
Gaze hand steering is a perfect example of this in action. You know how with a joystick you're kind of locked into moving in one direction? It makes it hard to look around. But with this multimodal approach, you point with your hand to set a potential direction, and you only start moving when you also look that way. The second you look away, you stop. This lets you freely look around the environment while you're traveling, and it just feels incredibly natural. And it also helps reduce motion sickness, which is a huge plus.
So the really crucial point is this. The new paradigm for VR design in 2026 is natural first, controller supported. This means you design the experience to be primarily driven by hands, eyes, and voice, creating the most intuitive and immersive foundation you possibly can. Then, you bring in the controller only where it adds specific value, for precision, for haptics, for certain gameplay mechanics. So, we've unbundled the physical controller into all its component parts. But what happens when we go even further? What happens when the input device is no longer your hands or your eyes, but your brain itself? Okay, let's look just over the horizon. If you think about it, the first era of modern VR was totally defined by the controller. This current era we're in is being defined by this multimodal mix of natural inputs. So the next era? It's poised to be all about neural interfaces, reading the body's electrical signals directly.
And listen, this isn't science fiction. This is happening in research labs today. Projects like NeuroGaze are already combining brainwave sensors with eye tracking to create interfaces that respond not just to where you're looking, but to the neural intent behind your gaze. There are wristbands that can detect the tiny electrical signals your brain sends to your hand muscles, often before your fingers even start to move, allowing for impossibly fast and subtle microgestures.
And this just perfectly illustrates the ultimate path of VR interaction, from a clunky physical controller to the biomechanics of our own body, and finally, to the signals of our nervous system. It's a journey toward an interface that is so intuitive it becomes completely invisible. So I'll leave you with this question. When there's nothing at all between our thoughts and the virtual world, what will we create?